Hey YouTube, welcome back to Intuition. In today's video, we're going to be answering some kinematics physics questions. Physics kinematics is a study of movement and motion, and the simplest question I can ask you when it comes to motion is asking you a question about an object that moves at a constant speed. For example, I can ask you, if you have a car or some other object that is traveling at 20 meters per second, how far will that object travel in 6 seconds? It's too easy, right? Because that's a problem that you can do in your head. If you're traveling at 20 meters per second, then every second you travel 20 meters. So after 6 seconds, you would have traveled 20 times 6 meters, which is 120 meters. Real easy, right? Now, let's take a deeper look at that question and see exactly what we did. If we plot our speed versus time, we were traveling at a constant speed at 20 meters per second, which means that our speed versus time curve is going to be a flat line because our speed never changed. So when we ask the question, how far did we travel after 6 seconds? What exactly are we asking for? What we're asking for is the area of this rectangle. What we have is a rectangle that has a base of 6 and a height of 20. The area of a rectangle is the base times the height, which is 20 times 6, which is 120. The distance traveled is the area under our speed versus time curve. And this was for constant speed, which means that we had an acceleration of 0, because acceleration is what causes you to change speed. So now let's see how things will look if we have non-zero acceleration. If we have non-zero acceleration, that means that we're either going to be gaining speed or losing speed. In this graph here, this is a graph of increase in speed, which is a positive acceleration. We're assuming that the acceleration is constant, which means that you're gaining speed at a constant rate, which means that you're gaining speed in a linear fashion. So this would be the equation of a line, and the slope of that line, which is the rate at which we gain speed, is the acceleration. So the equation of this line would be our v final, which is our v at some later time t, is equal to our initial speed, vi, plus a times t, right? Where a is the slope. If we want to get the distance traveled from time 0 to some time t, we just need to take the area under this curve, just like we did before. So when we take a look at the area under this curve now, it's no longer a rectangle. It's somewhat of a trapezoidal area, but we can break this area up into two parts. One will be a rectangle, and the rectangle has a height of v initial, and the base is t, and the area of this rectangle will be the v initial, which is the initial speed times the time. On top of the rectangle, we have a triangle left over. Area of a triangle is 1/2 the area of a rectangle. We do 1/2 the base times the height. The base goes from 0 to t, and the height now is the difference between v final and v initial. And of course, from our equation, the difference between v final and v initial is the acceleration times time. So the area of this triangle is going to be 1/2 the base, which is time, times the height, which is acceleration times time, which will give us 1/2 at squared. So that's at squared over 2. And now to get the distance traveled, all we need to do is add up these two areas. So our final position, called x final, is going to be equal to our initial position, x initial, plus the distance traveled, which is v initial times time, plus 1/2 at squared. And this is how you get the distance traveled for constant acceleration. Another way to get it is to think about the average speed. When we have constant acceleration, we start off with some speed called v initial, and we end up with some final speed called v final. Because the acceleration was constant, your speed increased linearly. And because your speed increased linearly, your average speed is going to be right in the middle between v initial and v final. That average speed is going to be the average of v initial and v final. And how do you get the average of two numbers? To get the average between two numbers, you just add the two numbers together and divide by 2. So now to calculate your final position from some initial position, it's going to be equal to the initial position plus the average speed times time. So here's another equation that we can use to calculate the distance traveled. And this equation is equivalent to the first equation that we just did. So now we have 3 equations, right? And we can derive a 4th equation by using the first equation to solve for time, and then plugging in time into equation 2 or 3. It's easier to plug time into equation 3. So if you solve for time from equation 1 and plug it into equation 3, you're going to get a 4th equation. That equation is going to say that your final position is going to be equal to your initial position plus v final squared minus v initial squared divided by twice the acceleration. These are the 4 equations for constant acceleration that we need to know to be able to answer a variety of different questions. So let's go ahead and answer some questions. Question 1 says, a particle moves along the x-axis according to the equation x equals minus 8 plus 6t minus 4t squared. With what average speed does the particle travel between 8 and 10 seconds? When you take a look at this equation of motion, it looks like our equation number 2. And for this question, what we're concerned with is we're concerned with speed. We want our average speed between 8 and 10 seconds. So we need to get our speed at 8 seconds, get our speed at 10 seconds, and take the average between those two numbers. From this equation, we should be able to quickly realize what our initial speed is, which is the speed at time equals 0. If we match this equation of motion that we're given for this object to the equation of motion that we derived earlier, we quickly see that v initial is equal to 6, and that is the speed at time equals 0, because that equation is derived from time equals 0 to some time t. So v initial is equal to 6 for this object. Out of this equation, we can also get our acceleration of the object, because the equation is x initial plus v initial times time plus 1/2 at squared. Now, if you look at the equation that we're given, the 1/2 a is equal to minus 4. Therefore, a divided by 2 equals minus 4. In solving for a, we get a equals negative 8 meters per second squared. The acceleration is negative, which means that we're gaining speed in the negative direction. So for this problem, our initial speed was 6 meters per second to the right, but we're accelerating to the left, which means that even though we start off with speed to the right, we're eventually going to lose that speed to the right, and end up gaining speed to the left. And to get our speeds at 8 seconds and 10 seconds, we can use our initial equation. Our initial equation was that our final speed is equal to our initial speed plus the acceleration times time. And when we plug in to get our speed at 8 seconds, we get our speed at 8 seconds is equal to 6 minus 8, which is the acceleration, and the time is 8 seconds. 8 times 8. And when you do this calculation, you get negative 58 meters per second. Okay, so that's our speed at 8 seconds. Now let's do the same thing to get our speed at 10 seconds. Our speed at 10 seconds is going to be equal to negative 74 meters per second. Okay, so now we got exactly what we wanted. We have our speed at 8 seconds and we have our speed at 10 seconds. So now we just need to get the average between those two speeds. And to get the average between two numbers, you just add up those two numbers and divide by 2. We add negative 58 plus negative 74 and divide by 2, and we get negative 66 meters per second. So that is our average speed between 8 and 10 seconds. And therefore, our answer is answer choice B, negative 66 meters per second. Okay, easy, right? Okay, let's solve a second problem. Second problem says, an arrow is shot upwards from a cliff that is 200 meters above the ground with speed 40 meters per second. If the arrow closely misses the cliff on its way down, with what speed does it hit the ground? Gravitation acceleration equals 9.8 meters per second squared. And this question says that we're on a cliff that's 200 meters above the ground, and we shot an arrow straight up, and the arrow goes up, comes to a stop, and then it comes back down and hits the ground. And we want to know with what speed does it hit the ground. Okay, we can do this. Okay, so since this question is only asking about speed and we're not given anything about the amount of time, we can utilize our fourth equation, which links our speed with our distance traveled. And what we're asked to solve for is our final speed. So we can manipulate this equation to solve for v final squared. And when we do that, we get v final squared equals twice the acceleration times the difference between our final position and our initial position plus our initial speed squared. Okay, simple equation, all we have to do is plug in. So we have 2 times the acceleration, and we're told that the acceleration due to gravity is 9.8 meters per second squared. And since gravity increases speed downwards, the acceleration due to gravity is going to be negative since it's downward. So that's 2 times negative 9.8 times the difference between our final position and our initial position. Well, our final position is on the ground. We want to know with what speed the arrow hits the ground. So the final position of the arrow is going to be the ground, and the level of the ground, we're going to call that position 0. When you're on the ground, you have 0 height, so that's 0. And our initial height, we shot the arrow from the cliff. And how high up was the cliff? The cliff was 200 meters above the ground. So initial position is 200. So that's 0 minus 200 plus our initial speed squared. And we're told that we shot the arrow up with an initial speed of 40 meters per second. So our initial speed was 40, therefore v initial squared is going to be 40 squared. And now we just need to plug this into our calculator. We get 5,520, and that is the square of our speed. So to solve for our final speed, we need to take the square root of both sides. And taking the square root is the same thing as raising something to the 1/2 power. So when we raise both sides to the power of 1/2, what do we get? We get 74.3 meters per second. So that is the speed at which the arrow hits the ground. And therefore our answer is going to be answer choice B, 74.3 meters per second. All right, easy. Okay, so there you have it. So we basically went through an entire chapter of first year physics for a lot of students. Hopefully this video was helpful. Let me know if you guys have any questions about it. If you're new to this channel, we welcome you to Intuition. Go ahead and subscribe, become part of our family. We release videos on this channel every week at least, and we focus on math, learning, and science concepts for the purpose of gaining a deeper understanding of how things work. And keep looking out for our videos every week. All right, with that said, I'll see you guys next week. Bye-bye.